It is December 25th, 2021, and a new window to the hidden secrets of the cosmos is opening for experts. About 6 months after the launch of the James Webb Space Telescope, the complex equipment provided us with the first overwhelming images. But this was only the prelude to an ambitious mission, at the end of which our knowledge of the universe will be lifted into completely new spheres. In addition to studying the first luminous formations and galaxies that emerged after the Big Bang, Webb's mission will also help provide the answer to one of the oldest questions in human history. Are we alone? To get to the bottom of this cosmic mystery, the $10 billion telescope will look at the atmospheres of exoplanets and check the celestial bodies for habitability. In this regard, the mysterious signal recently detected is becoming a particular focus of discussion. But what are these current headlines that tell of artificial lights on Proxima Centauri b really all about? Is it truly the technical signature of an advanced species? Or can the reports be explained in another way? Together with you, we're looking for answers today. Excited about the groundbreaking discoveries and fascinating spectacles in the universe? Then remember to subscribe to Simply Space and click the bell for regular updates on these exciting topics. Go ahead and show us with a thumbs up that we can keep you engaged with the content of our videos. Proxima Centauri b. It's a question that's probably as old as humanity itself. Are we alone in the universe? Given the countless entities that sparkle down at us from the firmament, is it even possible that Earth is the only celestial body that harbors life? The problem? Although researchers have now succeeded in detecting more than 5,100 exoplanets in nearly 3,800 systems, such a sensational find is still a long ways off. Not only have we not yet been able to prove the existence of extraterrestrial life, in fact, we do not know of any planet other than Earth that can be categorized without doubt as habitable. Often the enormous distances gaping between us and the extrasolar worlds represent a substantial complication for more exact analysis. However, things are somewhat different for our closest cosmic neighbor. No other exoplanet comes as close to our terrestrial home as Proxima Centauri b. Although there are just 4.2 light-years between us and this celestial body, its presence was only detected in the summer of 2016. Using the radial velocity method, the assumption quickly arose that the experts had encountered a cosmic twin of Earth in the course of their discovery. And it's indeed true that the exoplanet orbits its namesake host star, Proxima Centauri, within the habitable zone. As a reminder, in the world of astronomers, the habitable zone is the distance between a celestial body and its parent star in which water can exist in a permanently liquid form. And it's well known that the presence of liquid water is a fundamental prerequisite for the development of Earth-like life. On the so-called Earth Similarity Index, Proxima Centauri b reaches a value of 0.87. As this official designation already reveals, the ESI indicates how similar another celestial body is to our Earth. But does this mean that life is possible on Proxima Centauri b, or that it has already developed there? Well, according to our current state of knowledge, this question cannot be answered so easily because we simply know too little about our extrasolar neighbor. What is certain is that recent spectrographic analyses indicate that Proxima Centauri b has about 1.17 Earth masses. In addition, it can be concluded that the celestial body has a bound rotation, which means that it always turns one and the same side towards its central star. This circumstance would mean that the exoplanet is divided into two areas that differ drastically from each other. The day side, which is constantly illuminated, would therefore be significantly hotter than the opposite night side, which is plunged in constant darkness. The equilibrium temperature of the planet is estimated to be minus 38 degrees Fahrenheit. But even this value is anything but set in stone. If the celestial body has a dense atmosphere, its surface temperature would be significantly higher due to the natural greenhouse effect. Also, the report that Proxima Centauri b could host liquid water has to be classified correctly. The orbital parameters and atmospheric composition that led to this exciting result in a simulation may not match the actual reality. Mysterious signal. As just mentioned, Proxima Centauri b probably divides into a scorching hot day side and a bone-chillingly cold night side. However, this spatial division does not mean that the existence of life on the extrasolar world is categorically excluded. Between the two areas of extremes would lie a narrow band in which temperatures prevail that could pave the way for the development of life. And possibly the hypothetical inhabitants, just like us, managed to evolve over time from simple, single-celled organisms to a highly developed species. If this is indeed the case, such a civilization would have to have left traces on its homeland, traces that we can also perceive from our terrestrial vantage point. And indeed, in December 2020, a stunning discovery was announced that some experts interpret as just that, an artificially generated radio signal. The source of the mysterious signal could be located in the realms of Proxima Centauri. Originally, the researchers had dedicated themselves to the task of examining the host star for signs of flares. With the help of the Parkes Radio Telescope in Australia, the experts wanted to find out what effects these radiation bursts have on the surrounding planets. During the evaluation of the data, which had been collected over a period of 26 hours, Shane Smith, an intern with the SETI program, came across a conspicuous signal with a frequency of exactly 982.002 megahertz. Since then, this so-called Breakthrough Listen Candidate 1, or BLC-1 for short, has been considered an official candidate for an artificially generated radio signal from an extraterrestrial species. But that's not all. In the same period, other experts also came across a conspicuous feature in the Proxima Centauri system. The experts detected a bright, long-lasting optical flare there, which was accompanied by a series of intense, coherent radio bursts. However, the fact that BLC-1 does not currently rise above the status of an exciting candidate is due to the fact that scientists have not yet been able to classify the background of the signal beyond doubt. To prove that BLC-1 is indeed the technical signature of an extraterrestrial species, further observations are imperative, but astronomers have not yet succeeded in detecting the signal again. As a result, another origin, such as a satellite or natural source, cannot be ruled out. Artificial lights? Let us assume that life on Proxima Centauri b has indeed succeeded in blossoming in the form of a technically advanced civilization. Against this background, it would not be far-fetched that the exoplanet's inhabitants devoted themselves over time to the task of illuminating the pitch-black night side of their homeland world with artificial lights. The fact that the discovery of such a techno-signature is currently repeatedly associated with the future use of the James Webb Telescope is primarily due to the comments of Avi Loeb. The Israeli physicist has been searching for new ways to uncover the presence of our previously invisible neighbors for quite some time. In doing so, the expert does not shy away from unconventional paths. Accordingly, Loeb stated in 2018 that the mysterious Oumuamua missile could actually be the solar sail of an extraterrestrial species. Together with Eliza Tabor of Stanford University, the Harvard professor published a study titled Detectability of Artificial Light on Proxima Centauri b. In it, the scientists assume that the hypothetical species on the exoplanet uses a type of light similar to our terrestrial LEDs. The result? If the artificially illuminated night side reached 5% of the brightness of the day side, Webb could prove this fact with 85% probability. The principle here is that the more intense the artificial illumination, the higher the chances that it will be detected by our new eye in space. If the brightness of the night side were to level off at 9%, the probability of detection would be 95%. At first glance, an illuminance of just 5% doesn't sound like much, but unfortunately, this is a fallacy. For comparison, the artificial illumination of our blue home planet is only 0.001% of the reflected sunlight. In other words, this means that the artificial lights on Proxima Centauri b would have to be 500 times brighter than their terrestrial counterparts for us to recognize them as such. It's possible that the hypothetical inhabitants of the exoplanet have already provided us with some practical assistance in this regard. To reflect the host star's light onto the night side of the celestial body, the inhabitants could use dazzlingly bright orbital mirrors, which could also be seen by our telescopes. As exciting as the thoughts published in the study may be, we should remember that it is nothing but pure theory. At least for now, it remains to be seen whether the experts' theses might have a kernel of truth after all. Should Webb one day actually prove an artificial light signature on Proxima Centauri b, you can be sure that we will tell you about it here